Good morning. Uh, yeah, good morning, everybody. I see that 21 people, I think, are online in this course. Uh, can anybody confirm the fact that you are actually eating well or not in the chats of YouTube? Uh, okay, I see some answer. Great. So, welcome to the course of Applied Transport Modeling with Visum. Uh, Nice. I see some answers. So, thank you very much for being here today. This year, the classes are a little bit different from usual, and I will try to speak very slow and very clear for a very practical reason. We are trying to use YouTube because the servers of TUM well are overloaded with online classes. So we hope this way to be a little bit more stable in terms of connection. Um, However, there are always a few seconds of delay. So if you try to ask me something, it's probably going to be a few seconds behind for me. So yeah, just take into account this one when you do any comment. So wait, you can. Okay. So let's go through some practical uh, aspects of the course. First of all, so the content of the class of today is some practicalities for the course, the introduction, a short recap of transport modeling, what do we do, what we don't want to do, and also, if we do have time, some indication about the travel survey. Why? Because this is some of the most common type of data that we do use when we do transportation modeling. One also additional information here on the bottom, you can see the TUM tweet back session ID K1FA. So for those who do not have a Google account, they can go on the website and put this session ID, and they can also contribute, let's say, they can also contribute to the discussion that we are having, basically. Okay, just one second. I'm trying to organize my tabs in order to have an overview of all the discussion and conversations. So, an additional practicality, if you now go on Moodle, these slides that I'm going to show, including the session ID and all the information, are already available. So you can also check the class content in there. So, let's get started with the practicalities of the course. So this course is offered by the Transportation System Engineering Chair. The head is Professor Constantinos Antoniou, and the main two lecturer will be myself, Guido Cantelmo, and my colleague Moed Kurashi. As I said, we are still trying to provide the best service in terms of streaming and the best quality of teaching despite all the situation. Not everything is going as smooth as possible, so well, be patient with us if something is not perfect, and as soon as there is a problem, of course, reach any of us, and we will try to do our best. So, okay, some acknowledgement and some differences. The course is based on last year course as well as 2 years course, the course of 2 years ago. Why so? Well, because until last year, this course was organized jointly with the MATSIM course, and they were supposed to be taken together. And until 2 years ago, this course was organized by another chair. So this is why, in order to get the best possible, let's say, experience for the students who also have been doing this course in the previous years, we try to be consistent with what we did and what was taught before. Of course, there are some modification and some differences, but still some of the content is based on what was presented during the previous years. Registration and availability, I see that we have 33 persons here. I think that we had a total of 42 students asking for the course to be registered. My understanding is that we say that we are fine with accepting all the people who applied for this course. So as far as we know, everybody should be accepted. If there is some additional problem, again, write to us, we'll see what we can do. Of course, there is a limit in the course, but let's say if we're talking about 42, 45 people, it should be okay for us. Of course, if you do not intend to participate, let us know. Short description of how the course will take place. So I will be honest, I was not big fan of having live session, but we decided that for the first class, it was probably the best idea. The reason is the following. This course, it has been prepared so that you can work with the course material without necessarily the need to attend all classes. This was a specific, sorry, I'm looking on the chat and the camera is on the other side. That's why sometimes I can look confused, but anyway, the idea is that you should be able to have to pass this exam and to get a good score without attending all the classes. The classes should be a support for whatever is not clear. So in this sense, the course material should be self-explanatory. And in this sense, this is one of those few courses for which online courses might even help, because we can upload videos on how to prepare the network with Visum, how to organize the demand, and you can go over the video again if something is not clear. And because this is a very applied course where we do mostly work with the software, I think it should be fine. This is why if you look at the current schedule, we could change it. Okay, there is a question. Sorry, are we going to be learning MathSim also? No, not in this course. This year, as I mentioned, the MathSim and the Visum course are completely separated. So if you want to learn MathSim, you need to register to the course of MathSim. And differently from all the previous years, the two courses are completely separate. So you can take Visum as standalone course, you can take MathSim as standalone course, and whatever you get a good score in MathSim or a bad score in Visum, they are totally independent exams. I'm saying this because last year was the opposite. Last year, the grade was an average of the two exams. Okay. Going back to the schedule of the class, we have the introduction today, which is a very general introduction and overview of the course. Then we will have two classes that I will do for the next 2 weeks, Network Design 1 and Network Design 2. This will not be live session. We will upload the video, and you will be able to follow the video anytime you want, not necessarily during the hours of the course. Another reason for which I prefer this is that most of you students are now, I imagine, doing a lot of online courses, spending a lot of time in front of the computer, and we are trying to reduce this burden as much as possible. So for instance, today we will have a very short break, around 45, 50 minutes, 5-10 minutes break, because I would like to avoid you being 1 hour and a half continuously in front of the computer. If you are against this, you can write it in the chat. But because you are having a lot of class, I don't think it's nice for you to have 8 hours in a row in front of the computer. For the same reason, the other classes will not be online, but still we will have some live sessions in which you can ask us feedback and whatever is not clear. So, going to the installation of Visum and still some practical but a little bit less practical aspects. you can download the student version of Visum on this website. So there are some restrictions. You can use maximum A2 size when you print. You have a limit number of zones and links, which basically means the network you can model with this version is very small. And there is another limitation that is actually the most important. You have a limit of 45 minutes per session. What does this mean? It means that every 45 minutes, Visum will shut down. Now, before shutting down, it will ask you if you want to save, so you will not lose your data, and you can open it immediately after these 45 minutes. Again, take into account this when you are working, so try to save often so that you don't lose any progress. And I will also show you where to download the Visum file now. So let's see, yeah. So this is the web page where you can download Visum. It's really, really easy. You just have to select the version of Visum you want to use. Visum, that's important, not Visim. We want to download Visum. Then you will have to download all the information here, and you will be able to download it. You can also try downloading now, and if you do have any problem, you can tell us. For those of you who are working with Linux and with Mac, that could be a problem. So you might need a virtual machine, or you might need to have a dual booting, because Visum doesn't really work very well without Windows. So something to keep in mind for the next few weeks. There is additional software that you might need for this course, and this is basically R and or Python. So why we are talking about that? Well, in principle, you can use any software. If you are more familiar with MATLAB, you could use MATLAB. But during the classes, we will show mostly R and Python. So you are free to use whatever, but the material is based on these two. Why? What's the reason? Well, R is a programming language that is very suited for statistics and for creating very nice graphics. And there is a lot of statistics in some of the models that we are going to use. So some of the transport models that we are going to use need some inference, need some statistics to create the inputs for Visum. So we will use this software for manipulate some of the data that Visum is using. Now, what are the advantages and disadvantages? Well, Python is pretty much just a general purpose programming language. So in this sense, it can do pretty much everything. They both can do pretty much everything. The disadvantage of Python, or the advantage of Python, is that it has many modules, many libraries. It is open source, and even more important, it is compatible with Visum. So whatever you write with Python, you can run it directly inside Visum. And this is actually a big advantage. One of the advantages, I say, of using R is that for some functions, for some statistical computing, it could be easier or it could be more intuitive. Anyway, they are both amazing alternatives. One good option is to install Anaconda. Anaconda is free and open source distribution for both Python and R. So if you install this one, you will have access to both, and you can decide to use whatever is more convenient. No, this is the same. And this is just a screenshot of how these environments look like. So this is RStudio, which comes directly with Anaconda. And you will have a script space where you can write your code, a console output where you can write commands, a workspace where you can see the variables, and a plot space. Now, this is the advantage of these softwares, that for this specific, let's say, environments, you can actually see the variables, which for some, you have a graphical user interface that allow you to directly interact with the variables, which in some cases is very nice. And this is an example of Spider, which is, let's say, another environment for Python instead in this case. And you can see that it's pretty similar to Python. Well, it's dark side against the bright side, but the only reason is that this is from my computer and I like a black background. Of course, you can personalize it. And the idea is that you have a script space, once again. You have a console input and output, and you have a workspace. So again, this is important just because with Python, not all the environments provide you, not all the environments allow you to have a graphical visualization of the variables. For instance, if you use Jupyter, it's another amazing environment, but it's just not as intuitive maybe. And now for the last part of the practical information, the exam. The exam will be a single take-home exam for the entire model and will basically include questions about transport modeling with Visum, which means pretty much everything we will show over the next weeks. Why everything we show over the next weeks? Because basically you will be asked to go from the very beginning, from the input data, until to output and to scenario analysis. The difference between this exam and, for instance, another exam about, I don't know, planning with transportation system is that most of the input data will be provided to you. So we are not going to ask you to look for the data, look for statistics. We are going to provide you most of the data, and you are going to be asked to work with Visum mostly. So another very important actually point about the exam, that's something I never stress enough during the courses. No more question, good. It's very important the way you write the report. During some exams, during some years, we had some students who were submitting only screenshot of Visums with very short description of what was happening behind. And despite knowing the fact that they did many things, despite having the Visum files attached to the exams, that's part of the evaluation. So your evaluation, you will be asked to submit also the Visum files because we need to be able to double check what you have done, but the evaluation will mostly be done in what you show in the report. So just to make an example, if in the report you just mention, we did some modification in the infrastructure, I cannot evaluate which kind of modifications you have done. You need to be more detailed. We identified a problem in a certain link, and we decided to take this action. We identified that there was congestion in this part of the network, and we decided to take this action. So the report needs to be self-standing. We do not need to go through your Visum files or Excel files to check what you have done. That's very important. Eventually, at the later stage of the exam, we can provide maybe a couple of examples from the previous years, or what is a good example of report and what is a bad example. Just general information, I have a message that the connection has been lost for the tweetback. So I think I'm losing the chat there. Let's see. If it doesn't work, I will open a new one. Just 1 second. Let me. So meanwhile, when I'm trying to open again tweetback, is there any question for this first part? Because from my side, we mostly finish with the practicalities about the exam. So we're gonna now move to the content, an overview of what are the objectives. Okay, I will go ahead now. I'm trying to create a new chat for tweetback, but right now it seems like the chat there is not working. So as soon as I manage, I will take another short break and try to open a session there. Okay, now that we finish with the, let's say, bureaucracy and the practicality about the project, we can go through the main content of the exam, of this course. So, what are we talking about in this course? We are talking about transport modeling. What is transport modeling? Well, a very famous quote from George Box is, all models are wrong, but some are useful. This is one of the quotes that one of our previous lecturer was in love with, and there is some really wise advice behind this. And the wise advice is that we are creating a model here, and we cannot expect this model to recreate reality. So we have to ask ourselves, why do we need transportation modeling in the first place? The reason is the following. People need to go to work, people need to go to school, and need to have an efficient service that provide them with the possibility to move. If the demand exceed the capacity of the infrastructure, then we have congestion and we have missed opportunities. People might not be able to go not only to work, but also to do other activities like leisure. This will create economical losses as well as missed opportunities. And this is what we want to avoid with transportation model. So with transportation modeling, we want to be able to forecast the future, to forecast what's going to happen tomorrow so that we can provide the best experience to the users in terms of transportation. And these models have been used for over 70 years now. So we are talking about something that is very, very well known from the side of policymakers, but it's also something that is evolving all the time because it's something very complicated. And it's important, once again, to understand that what we want to achieve here is just to be sure that when we invest in the transportation system, we do it wisely. Why? Because most of the money that we spend come from the public authorities, come from the taxpayers, and we want this money to be spent wisely. I apologize, by the way, with the people who are not in the chat of YouTube, but right now, tweetback is not working. Once again, this is why we switched to YouTube to avoid having problems with this one. Maybe there are too many sessions in tweetback at the moment. So I do apologize if somebody doesn't manage to write me, can send me maybe an email later. Oh no, wait, it's working finally. I'm gonna write in the chat the new session ID. And there we go. So now that everybody can make questions, transport is all about choices. And there are many, many transport models around. We are not going to cover all of them because this is not transport modeling, it's transport modeling with VISUM. But in general, we need to have an understanding of what's happening behind the software in order to understand the output of it. So all transport models can be roughly or broadly divided in three categories. One is the demand, one is the supply, and one is the activity system. So what are we talking about here? So when we talk about supply, we are mostly talking about transport facilities. So we're talking, for instance, about transportation infrastructure in terms of how many highways we have, how many kilometers of road infrastructure we have, if a certain area is connected or is not connected. We are talking, of course, of by their characteristics. For instance, you might have a road, but it's pretty different if you have a primary road or if you have a motorway. If you have a motorway, you are talking about large flows. If you have a small primary roads, you are probably not expecting a lot of people moving on that segment. And the last element is the transportation, is the level of service or the performance or your characteristics. So let's make an example for each of them. Let's say we're studying the transport infrastructure connecting Munich and Berlin. So the fact that we have the facilities represent the fact that we have train connection, that we have airports, that we have motorways. The supply characteristics represent the fact that the road that is connecting Berlin and Munich is characterized is a motorway. Is the autobahn. There are no speed limits. There is a certain number of lanes. While the service performance is basically how well the infrastructure is working. We have a motorway, but is the motorway fully congested, or is the motorway working, or is the motorway always empty? So the relationship between basically performance and capacity is given by the congestion. For the demand, it's do we have people who are willing to use this transportation system? So it doesn't matter we don't need to create supply if we do not have demand. Demand is how many people, for instance, are moving from Munich to Berlin every day for commuting, for instance, not so many, probably. If we are talking about different trips, we might have, if we are talking about goods, for instance, we might have. So yes, Moed, I wrote the tweetback ID. So this, I will write it again. So the demand represents people who, sorry for the interruption. The demand represents the people who want to actually use this infrastructure. And this depends on a lot of different options. We can, first of all, classify the demand based on the mode that they are using. We have to understand that the demand has temporal and spatial characteristics. So we have the demand going to Berlin from Munich, but also from everywhere else in Germany. We need to understand the fact that we have different networks, different transportation networks. So now we have been talking about motorways, but as I mentioned before, we do also have the rail network. We also have flight connections. And last but not the least, a very important element, which is very often underrepresented in many models, is the activity system. So the reason why we have interaction between the demand and the supply is the fact that actually people move to achieve a certain purpose. People move to go to school, to go to work, to go for some leisure activity. So the activity system explains us why we actually move. And this is actually one of the most complicated elements, because the way in which I'm doing choices today is different from the way Moed is doing choices. It's different from the way any of you is doing choices. And as a concept, but the overall demand on the system is a combination of all of our choices. And this is why the model is going to be wrong, but it can still be useful. We are not pretending to understand what each single user is doing. We are not pretending to create a big brother that is following every person from the door to the destination. We just need to understand why people need to move and where do we need to actually invest. And this framework, as I mentioned before, is used to forecast the demand, to understand how much demand do we have, and to understand if this demand exceeds the capacity or not. And is then used for planning purposes. Planning purposes, it means several different options. You can use this type of approach, for instance, for short-term planning. Even, for instance, for predicting what's going to happen this afternoon. So you might want to predict what happened in a few hours in order to, for instance, do some improvement in your infrastructure. For instance, you may decide to do real-time traffic control. What does it mean? It means optimizing in real time the timing and the signals of your traffic lights in the network. Why? Because you don't want, for instance, to give too much red to road segments that are empty. You want to give more green where it's needed. Or for instance, you might want to put more buses if there is a peak in the demand for public transport. So there is then, let's say, middle term planning, which is something that usually is about 1 year, maybe few years. And that could be something like reallocating resources. One example of this could be you want to create a new public transport line, or you want to redesign your public transport network. So you might not want to build new infrastructure, but you might want to move some buses from one line to the other. And to do that, it's not very expensive, but still you need to understand to put buses where they are needed, because otherwise you might even create a new transportation system that is actually weaker than the one before. And finally, long-term planning, of course, it's when you actually need to create new infrastructure. You want to create new infrastructure that's pretty expensive. You need to be quite sure transportation modeling. Actually. Well, transport is all about choices, as we say. So at the end of the day, most of the models we are dealing with try to simplify the process as follows. Each of us, at the end of the day, does some sort of choice. For instance, after this class, if there was no the corona crisis, you could have decided whatever to go for shopping, or maybe to stay at the university and learn and study a little bit more. And that's the first choice. The second choice is, the second choice is where to go. If you decided to go for shopping, well, then you can go to Mariensplatz or you can go to Olympiazentrum. And once that you decided, you still have to decide how to go. Are you going with the U-Bahn or are you going with the car? And finally, even when you decide to take the U-Bahn, for instance, you still have several options. So all of these elements need to be included in the transportation, in the model that we are building. All of these choices need to be explicitly represented in order to understand, once again, where there is demand and where do we need to act. And this is why one of the oldest, most widely criticized model ever, but also one of the most widely adopted, is the four-step model. The four-step model basically just introduces a sequence of choices which work exactly as we just described. So first of all, we have a series of data. So we have the first one, what is zonal data. What is zonal data? It's the fact that you are, for instance, we are talking about Universität, we are talking about Mariensplatz. Different areas may have different characteristics. Then for each area, we have to understand how many people do the decision to move or to stay. And for each other area, we also have to decide how many people are arriving to this area and how many people are leaving the area. So this is what we call production and attraction. The production is how many people decide to move from that area somewhere else, and attraction is how many people decided they want to go there. Then we have the distribution. The distribution is basically where people are going and where people are coming from. So if we understand that, for instance, there are a few thousand people that are moving from Mariensplatz, we still need to understand where these people are going. And if we see that there are a few thousand people going to Mariensplatz, we have to understand where these people are going, where these people are coming from. And this is basically the trip distribution. Then we have another choice, which is the modal split. How are you going to do? You are going to go with the with the U-Bahn, with the car, with the bus, with the bike. Last but not the least, there is the traffic assignment. Now, the traffic assignment is an extremely complicated problem, and to be honest, is the main reason why we are actually using Visum. But to simplify as much as possible, it's mostly about route choice, which means, as we said before, if you are going from Universität to Marienplatz, you might have different routes. Now there is one more level on top of these four choices, which is the travel resistance, and specifically the fact that you are not the only one using the infrastructure, but you sometimes are competing with other users for the same resource. So, for instance, you might decide usually to go by car, but if the road is fully congested, you are probably going to go by U-Bahn. So somehow, these decisions are all connected, and you need to consider the interactions between these decisions. You are not a robot that decide, okay, I'm going to Marienplatz, I'm going to go no matter what. I'm going to go if there is a connection, if there is not too much congestion, if I have the car. So this is once again the most general and superficial description of transportation modeling that we can think about. The idea is that during the course, we will go a little bit deeper in all of the concepts that I just very briefly introduced today. And we are gonna to see specifically what do we need to know to implement this concept with Visum. Because we need specifically at the end of the day, at the end of the course, we need to work with Visum. Also, why do we choose Visum? Well, it's a very practical choice. Visum is a German company, PTV is a German company, but is also one of the most widely adopted softwares in the world and in German. So the idea is that at the end of this course, you need to be able to write on your CV that you are able to use Visum. That's because a lot of companies, from BMW to public operators, do use Visum. So it's important to understand the software and to understand the basic mechanics behind the software. Disclaimer, despite the fact that this concept has been around now for more than 70 years, it's still an active field of research. So there is no one, in other words, there are always many ways of doing things wrong. There are few ways of doing things right, but there is not just one solution that applies to everything. In transportation, we need to think and we need to analyze what's the best decision to make in each specific situation. So that's something that we have to take into account. We are going to give a very general overview. This might not always be the best practice. This is just the standard and the basic mechanics behind transportation modeling, behind working with Visum. Okay, so things you probably should know, or we hope that you know. So a short recap of, once again, how we try to consider all these elements that we have been briefly analyzing until now. I think actually this is maybe a good moment to take a short break, because we have been roughly 40 minutes, I think, in the video. So we take a short break, 10 minutes, and 2:05 we go back online. Okay? So see you in 10 minutes. 10 minutes sharp. So there we are again. Should I leave a couple? Okay, I can start slowly talking because this class is extremely light anyway. It's just the introduction and the recap. And I hope we didn't lose too many students in this short break. One question here. So this is now a single course. I receive a question if this is now, if this, is there an additional lecture in the winter term or is this now a single course? No, this is a single course now. We receive a question from the students. Yes, sorry for not answering before. So short recap. So as we mentioned before, these are things that we expect you to know already, but I receive another question. No, it's a comment. So again, if you have additional question, maybe let's save 5-10 minutes at the end of the class, okay? In principle, it's very good to have interaction. If you have questions on the slide directly, then do it immediately. Maybe more general questions, we can say 5-10 minutes at the end of the class, okay? So going back to the topic. So the first thing that we have to define when we work with the transportation and transportation modeling in general is to define the study area. So when we build our model, we have to consider, we might consider the entire Germany, we might consider the entire Europe, the entire world, only Munich. How do we decide that? Well, mostly it depends the dynamics we want to capture. If you want, for instance, to understand what happened in Germany, you might need a very detailed model of Germany, of course, but you might need a less detailed models of Munich. And you might need a not so much so detailed model, but some model of what happened outside Germany, in France, in Belgium, in Luxembourg, in Switzerland. Why? Because these are the areas around your study area and somehow they influence it. So in our case, now we are going to work at the city level. So in the case of Munich, for instance, this could be one example of the study area. We don't want only to have, let's say, the inner ring or the city center. We want to have something a little bit larger. Oh, sorry. Okay. So traffic analysis zone. What is this? Well, traffic analysis zone, it is how big. Once that we have defined our study area, we have to divide it in a certain number of zones. So inside the study area, we will have a certain number of zones, which depends once again of how accurate our model needs to be. So in the case of Munich, for instance, we could divide the entire model in two areas, like Munich East and Munich West, but that will not be really realistic. So it's always a trade-off. If you make too many zones, you make zones of 500 meters, then it's very realistic maybe in terms of traffic, but it could become less realistic in terms of data. How do you understand how many people are really going to travel in those 500 meters instead of the next of the traffic zones just next to it? So the traffic analysis zone basically defines the level of detail of your model. And it's always a trade-off. As I said, more zones is more detailed representation, but it comes with a higher cost. And another thing that you have to define is the external zones. So we have defined Munich as our study area. Still, we will need to define some external zone. What is an external zone? The rest of Germany, for instance. So we might come out with at least 4 external zones. One of them is whatever happened east of Germany, of Munich, whatever happened in the west part of Munich, whatever happened north and south. Why? Because of course we have a lot of people who are coming to Munich for work. And we need to consider this. If we imagine, that's actually one of the key aspects of your transportation system. Transportation systems, they are all connected. Transport is all about connectivity. So if you just cut your study area outside everything, that's just gonna be wrong. So this is one example of traffic analysis zones. Here we are only looking what happened inside Munich. But this is, for instance, a relatively good trade-off. Why it's a good trade-off? Because as you can see, we have quite some level of detail, specifically in the center. But at the same time, the data for these areas are relatively easy to retrieve because we have quite some overlapping with the administrative areas and with data that are available. So this is also another criteria. You should not only look how detailed your model, how detailed you want the model to be, but also how detailed the data that you have are. And this is how do we start modeling the interaction of one traffic analysis zone with the others. So this is, for instance, the city center. What you can see in this slide in blue is what we call the center of gravity of the zone. And what we see in green is the connector. What do these things represent? Well, the center of gravity is basically where we assume that all the demand is generated. Usually, for convenience, you locate it at the center of the study area, like in this case. But actually, this doesn't really represent anything without connectors, so you can, to be honest, put it everywhere you want. Because what really makes the difference is the connector. What is the connector? The connector connects the center of gravity of the zone with the network. So as you can see here you have that the center in blue is the connector, and these two segments are connecting the center of gravity to the network. So it means that whatever demand we have in this area is gonna be loaded, is gonna access the network in these 2 points, and only those 2 points. If we assume that this is not realistic, that maybe we want a more distributed demand, for instance, then we can add 1 more connector, or 2 more connectors, or 5 more connectors. So the connectors actually represent where your demand start or finish its trip. So everything starts and ends in the centroids, and these centroids are connected using the connectors. Once again, we will see how to do this in VISUM in the next class. But this is just to give an idea. Connectors are actually some of the most important part to properly model transportation system. We don't consider the internal, thank you for the question, and I try to always answer. We don't consider the internal trips in VISUM. Yes and no. For yes and no, it means the short answer is no, you don't. Because even if you do model some trips, with this type of representation, these trips will not be generated in the network. So the short answer is no. You can, of course, kind of estimate the fact that there is some demand inside, but the idea is that you shouldn't have too much demand. If you have too much demand in one zone, then you probably should split the zone in smaller zones. So this is a very good question. And considering the connectors, as I mentioned before, connectors they do not exist in reality. And this is also important to understand because conceptually, they have an infinite capacity. You can have 1 million people on one connector, and this will still be fine for the connector. The problem will come on the network. If you start to load 1 million people in one road, or in 2 roads, like in this case, that's not going to be realistic. If you have 5 people connected with 2 connectors, that's realistic. If you have a few thousand people, that's also realistic. What also has to be considered? It has to be considered the infrastructure per se. So if the connectors allow more or less the flows to distribute in an homogeneous way in the traffic zone, then it's good. If it doesn't, then you need additional connectors. So let's see one example once again. This is our study area, as we mentioned before. And this is the first step of our 4-step model. So what do we have? We have the production and the attraction, as we mentioned before. So for instance, if you look in the top right of this presentation, we have what we call origin-destination matrix. What is an origin-destination matrix? Origin-destination matrix, it means that you have the traffic zone of origin, in this case zone 1, and the traffic zone of destination on the columns. So the rows are the origins, and the columns are the destinations. And the sum of all the originated trips give you the production. So the first step of the four-step model. So for instance, we have 2,500 people from zone 1 and 5,000 almost people generated from zone 2. And then we have the attraction. So we know that 5,000 people are going to zone 1 and roughly 2,300, almost 2,400 are going to zone 2. So this is the first stage, the first step. And we have this information for all the zones in the area. And how do we get this information? Well, usually the production is obtained as a function of the population, how many people are living in a certain area, and the attraction is given by how many people are working in a certain area. Of course, this is the simplest case, when we are only considering home and work commute. If we have better data, and if we have different data, we can do the same approach, for instance, for not work-related trips. So we can also see how many people, for instance, are going to do some shopping. But of course, we need different type of data. And we are going to see that with the travel survey. How do we understand how many trips are generated for each activity purpose? But once again, this is about the data, while the trip generation is something that you can do everywhere, for regardless the data. In the easiest case, just for the home work commute. Then, phase 2, the trip distribution. As we said before, trip distribution, it says, okay, where these people are actually coming from and where they are going. So for instance, in this case, we do find out that we have actually 1,000 people of internal trips for zone 1, and 1,500 people are going to zone 2. While for instance, for zone 2, we have that 4,000 people are going to zone 1 and roughly 1,000 are staying. How do we calculate these distributions? How do we know that 4,000 people are going in zone 1 and 1,000 people are going in zone 2? Mostly with assumptions. Once again, the better data we have, the more data we have, the less we need strong assumption. The least we need a strong assumption. If we really don't have data, we don't need really strong assumption. So for instance, one of the most common approach, once again, one of the oldest, most widely criticized approach and still widely adopted model is the gravity model. How does the gravity model work? Well, the gravity model says that basically, if you have that bigger zones have bigger attraction and bigger generation. What does it mean? It means that, for instance, if we look at this example, we see that clearly if zone 1 is attracting 5,000 people, most of the people generated in our network are going to go in that network. What is the use of mobility rates? Is it the same as production attraction rate? Can you be more specific? Sorry, we got the question in the chat. So formulate again the question, and I will finish the concept of gravity model first. So concerning the gravity model, as I was saying before, what happened is very simple. The bigger are the areas, the more attractive they are. So if we know that 5,000 people are going to zone 1, and if we know that a lot of people are generated from zone 2, so for instance 5,000, then a lot of people will be traveling from zone 1 to zone 2. So this is the assumption of the gravity model. Why is it called like that? Because it takes the inspiration from the gravity law. Bigger planets, bigger mass have more attraction power. Here is the same. If you have a lot of attractions, you have more attraction power. Of course, this is not the only difference. You also have some sort of resistance. What is the resistance? The resistance is how far two zones are. So in the gravity model, and this is one of the biggest limitations, zones that are next to each other are more likely to attract each other. So for instance, if zone 1 and zone 2 are one next to the other, they are very likely to exchange demand. If they are very far away, they are less likely to exchange demand. And very far away is not just geographically, but is in terms of transportation. So for instance, even to zones that are very far, if they are connected with a motorway or with the U-Bahn, they can exchange in this model a lot of demand. But if the connection between the two zones is not very good, then the model will probably not provide very good results. Another very important model is the mode choice. Mode choice basically is the choice of how are you going to travel. As we mentioned before, we have done our first two choices. We know how many trips are generated, we know how many trips are attracted, and we know where these people are coming from and where they are going. Now we need to understand which mode of transport are they using. I'm not going to enter too much into details of the equations, but the point is that usually we use discrete choice models. There is an entire course dedicated to discrete choice theory in the winter semester, very good course. We advise to go for it, of course. But conceptually, there are two things to understand. The first one is that this is a probability that depends on certain cost. What does it mean? It means that the probability, of course, is going to be higher for the most convenient mode of transport. For instance, if you have that public transport is taking 5 minutes and car is taking 50 minutes, this model is going to say that it's way more likely that you are going to take the U-Bahn, the cheapest one. The second thing is to understand that the cost of mode of transport can depend on several factors. Of course, travel time is one of them, but there is also the monetary cost. So the fact that you are paying a ticket or not, the fact that you are paying the insurance for your car, and in this sense, you might even be willing to use it. The fact that there is comfort or not, because even if there is good connection with the U-Bahn, for instance, let's make the example. If you want to go usually from Munich from Marienplatz to Universität, well, the U-Bahn is clearly the best option. It takes no time, it's very high frequency, and so on. However, personally, but I think it's not only me, whenever there is the match of the Bayern München, I'm not using the U-Bahn because I'm going to wait a lot of time to finally get able to enter into it, and I will be squeezed. It will be a lot of people sweating, drinking. It's very nice, but maybe if I just want to go to Universität, I prefer to walk or to take the bike. So cost is not only travel time, it's a series of factors. And all of these create a final cost, and you're going to choose probably the option with the lowest cost. Now, the second element that is important to know specifically, once again, for applied transportation modeling is the scale factor. What is the scale factor? The scale factor says how much stochasticity there is in your model. So basically, if you push it to the extreme, the mode choice could be entirely deterministic or entirely stochastic. What does it mean? It means that, for instance, if you have two options that is 1 minutes by U-Bahn taking a certain route and 49 minutes by the U-Bahn taking the other route, which model are you going to use? Well, the answer is it depends. If you use a deterministic model, it means that everybody will take the shortest option, so the 49 minutes option. If you have real-time information, this could be true. If everybody has real-time observation, if everybody is opening the application and it says that there is an option that takes 49 minutes and one that takes 51, probably they will all go for the option which is fastest, the fastest. But if you are not sure, if you are not checking the application, or if instead of traveling by U-Bahn, you are traveling by car, where you have an estimation of the travel time, but you don't have really any information, and if you have it might not be that reliable, then two options which are 49 minutes and 51 minutes are roughly the same. So probably the split will be 50-50. So this is exactly how the mode choice works. So it says not only you have the tendency to go for the cheapest option, but actually you have also sort of tendency to distribute between different options and not necessarily to always and constantly go for the cheapest one. Traffic assignment, as I mentioned before, this is a very, very long topic, very, very long discussion. It's not only about transforming trips to routes, but this is the main output. Why is not only trip to routes? Because, well, the traffic assignment is really about the interaction between users and infrastructure. So trip to routes is somehow the output, but what happened behind the model is way more complicated. And once again, we are going to have a dedicated class only on this, but the idea is that we have different assumptions which lead to different assignment models. Also here we have different approaches. We might assume that there is a deterministic equilibrium or a stochastic equilibrium, and each of these single assumptions will lead to completely different output of the networks. And this is the key aspect to keep into account, because we are doing all of this because we want to do, at the end of the day, some analysis. It is more convenient to have more U-bands on the U6 lines. It is more convenient to put more buses. It's more convenient to build new infrastructure. And at the end of the year, this decision will be decided on the output of the traffic assignment. And the traffic assignment mostly depends, once again, on how realistic all the choices that we have done are. So this is why it's important also when we really look at the applied side of transportation modeling to have at least some insights of what's the theory behind. Because otherwise, if we just start playing with Visum without taking into account about this level of knowledge, without this very basic mechanics behind the software, we are not going to get anything good. Actually, as we always say, garbage in, garbage out. So unless you actually really spend quite some effort in understanding what are the conditions that recreate the reality and that recreate a close approximation to what happens in reality, then your model is going to be completely useless. So how do we do this? Well, it's not going to be the topic of this course, but just to have once again an overall picture of how things should be done, we do calibration of these models. So all of the parameters that we have discussed, they can be calibrated. So we can make some analysis on the distribution of our demand to see if our demand actually match some other data that we have, and we can do calibration of the choice model to understand how much stochasticity there is in the system, if the model is more deterministic or stochastic, is people have the tendency to use more the car or more the public transport. All of these elements can be calibrated and need to be calibrated, because otherwise, of course, we cannot learn anything useful out of this model. Once again, there is an entire course about the calibration of traffic models, also in the winter semester. So that's the way to do it, to make it simple. So, summary and data requirement. Just to be very generic, what we need to run our Visum model is network data, first of all. So that will be the first thing that we are going to analyze next week, how to obtain the network data. We showed a very nice area of Munich. Of course, you can create this zoning from a map, but then you need to implement it in Visum. And again, this is an applied course. Sure, you can design the entire network of Munich from scratch, but there are smarter ways to do it. And usually that should be the first way to explore, the first thing to be explored. Once again, we have to understand, to get the data for the traffic analysis zones. What does it mean? It means, first of all, to understand which data we have, which level of detail we have, and then try to define our traffic analysis zone in order to be as realistic as possible under all point of views. So not to be too large, but also to try to kind of be comparable or to be able to represent our data. If we do too many small zones and we have to make too many assumptions of our data, the model is not going to be realistic. Trip data, that's something we are going to show quite quickly in the next 15 minutes. We need also to have some information about the trip, mode choice data and route choice data. Once again, we need to have some data also about this, or if we do not have the data, we cannot really be sure of the outputs of our model. Last but not the least, data collections. So the main data source for the first data source that we usually use when we deal with the transportation modeling is household travel survey. It is time consuming, it is old fashioned, but it's still the most widely adopted. And it's probably going to be the most widely adopted for quite some time still, because we can run it for nationwide usually. Almost each country does some household travel survey every few years. Of course, we can also do something more in detail and use data loggers, but usually this is more limited in size, and this is for having a better insight of what happened in the mode choice model, for instance. In the moment in which we want to understand multimodality, in which we want to understand trip choice, not trip choice, let's say activity choice, or understand sequence of activities, then we need more information. And for this more information, we also need better technologies like data loggers, for instance. Once again, we can also use mode choice with stated preferences or revealed preferences. And finally, we can do data collections at a network level, which, for instance, it means traffic counts. Traffic counts, it means if we want to calibrate our network, we can once again have a first model, which will probably be wrong. We create some simulated network data, and then we can compare this network data with the real one and see that the model is quite wrong, and then go back to the model and try to improve it. So I think maybe because we are almost at the end of the class, we have 10-15 minutes, maybe we can go through some questions, and the household travel survey will be introduced by my colleague who's going to talk about the demand models. Unless there are no questions, then I can bother you for 10 more minutes. But for instance, there was one question before I didn't answer, and there were a few questions about the courses. So first of all, some feedback. How was this remote class? Because for me, it's very difficult because we don't get a lot of interaction. So I don't know if everything was clear and if maybe we should explore some different ways, or if this is fine. Thank you. So we got one answer, this is fine. So again, there is some delay in the streaming. So I will just leave you maybe, I think anyway, there is no need to rush through the household travel survey. So let's spend some more minutes on questions. We have 10. And if there is no question, whoever is fine with everything, we will upload the next video next week. If you have additional question on everything from the, let's say, theory, practicalities about the course, specific problems that you might have, you can write me now, or you can write me an email, of course. Okay, is there any procedure or principle while dividing the zones in an area? Uh, Not really. So I can go once again to the slide. Um, and what Moed is saying is true, but is not all. That's the point. Uh, we should minimize the internal trip, as we say, but this is, I mean, he cannot talk, so he has to be quick in his answer. I don't want to say that Moed is not right. He's absolutely right, but that's not the entire story. So uh, once again, it depends on a lot of things. So first of all, let's say that you have infinite data. So you have information at the individual level, household, the street, the number on the door, wherever they live. Then what's and also exactly, and also you have the super detailed and most detailed infrastructure level. Then in principle, what Moedi says is right. And not only in principle, we can say, okay, at this level of detail, we can go almost at an individual level. We can create traffic zones that are very small. But even there, this is not super correct. Why? Because if you have the entire network, if you have the entire all the roads, including those roads that are not even reported on Google Maps, then your model is more likely to introduce errors. So the first criteria is first define the network. First, you should define the network and the level of detail of the network you want. Usually, because as I said, you bring a lot of errors with you in all this process, you don't want a network that is too realistic, which means it includes all those streets that people don't really know or don't really use, including the shortcut that is passing through the basement of your apartment. No, we don't want to get this one. We don't want the escape route for the heist in Casa de Papel. But at the same time, we don't want to aggregate everything. We don't want to have only the motorway. So the first thing is we want to have a balanced network. Then once that you have a balanced network, even if you have perfect information on the demand, you need, yes, to minimize the internal trips, and you need to have realistic flows on the network. So it's important not only how you divide the traffic zones, but once again is extremely important the connectors, where you put the connectors. So I would say that the first criteria is define your network. And given the network, then you can divide the traffic zones, doing this compromise that we were saying before. The idea is you minimize the internal trips, and at the same time, you take into account the level of detail that you have from your data. If your data cannot be split into half, for instance, then maybe there is no need to split a zone in two, because it's purely assumption-based, whatever demand you get there. If you have more accurate data, then you can try to push maybe a little bit more. But I would say once again that the first criteria is always the network that you have and the purpose that you want. For instance, if you want to design motorways, you might not care too much of what happened in the secondary roads, and you can have bigger zones. If you want to understand the traffic inside the city center, you will need more detailed zones. So it's network and a lot of experience and understanding the phenomena you want to represent. Thank you. Do you have any idea when the MathSim course will be open for registration? No. So maybe send me an email about the MathSim course, because this is new for us too. Last year was one module. So it can be that you maybe register the same way as last year. But as far as we have been told from the department, Visum is a totally different course, and MathSim should be a separate course, and I assume you should be registered already. So as far as I know, the MathSim course has closed the registrations. We have one colleague from our chair also teaching MathSim. So if you write to me, we can try to see what's your situation. And that, by the way, applies for everybody. So I receive a couple of messages. I don't know if it's one person or more with this problem of MathSim 3 credits or 6 credits. So whoever has this problem, somebody did already, send us an email and we will see what's happening. Okay, once again, I'm gonna stay 4 more minutes because that's the time, the class time, but whoever has no question, that's it for today. It's very awkward to be in front of the computer, I have to recognize like that. Thank you. That's a good point. Last year we did, so concerning the exam, is it a single take home exam or a small group project? Last year we asked people to do the exam in 2, so small groups. I assume that this year we will do probably the same. But as I said, it's slightly different because it's an entire course this year. It's 6 credits plus there is the corona problem. So let's see. Actually, this could be also interesting to know from your side. So considering that you might not be able to meet, would you like to have a group project? So of course you don't have to answer now. You can maybe discuss and maybe we can finalize this point during let me see the calendar. We have one live session there you go. We have one live session the 13th of May. So we can maybe try to confirm this that day. So you can let us know what you prefer. You can bang the tables. Yeah, good question. So the short answer is no. Of course, we are the best in teaching Visum. Nobody does like us. But no, seriously talking, there is some pretty good material. But once again, the best material, it comes from Visum. So my suggestion is for the course, you don't need anything but this material. Uh, Visum comes with a tutorial. This is the one we will ask you to do on the 13th. So hands-on practice. During that day, we will simply link you to the material from Visum, and you will just have to complete the task that the Visum tutorial asks you to do it. And the reason why we decided to go for this one is because it's a very complete tutorial. On the other hand, it doesn't provide all the information that we have been telling you. It doesn't enter so much into the detail for connectors, traffic zones, data, and so on. In addition to the material, there is some material from PTV online on YouTube. It's very good, it's very well done, but it's very advanced. So you might consider it if you have some special need during the project or after. I can recommend definitely to look for the PTV channel. They have some classes. They also teach the very basics of Visum, but for those, I never tried them, and I prefer our way because we start from the theory, so from the traditional methodologies, and we bring these methodologies into Visum, while they start from Visum and what is inside Visum. So that's the only difference. Exactly. Okay, so the class is over at this point. So class dismissed. Thank you very much for being here today. And again, let us know if there is any problem. Otherwise, you will hear my voice again next week. Have a nice day and stay safe.